this session, and I'm very pleased to have with me Ali from Seiko and Roland from LMS. And the two of these guys are going to be chatting a little bit about proofing for packaging. And we're doing this as a virtual, gives us a bit more time to get into the detail. And I hope that we'll kind of give you a bit of insight into the relationship between Ali and Roland in terms of the two businesses, and perhaps just kind of open up a little bit of those questions around why proofing is really important in the packaging sector. So Ali, give us an intro of yourself. A lot of people know you. You're a very popular guy. Whenever we share stuff on LinkedIn, you always get loads of likes. So tell us a bit more about you if anyone doesn't know you already.
Thank you so much, Faiza. Hello, everyone. I'm happy to be here. My name is Ali Pereira Purvala. It's a long name, but I go very well by Ali. Coming from India, moved to Germany in 2011 and completed my master's and was roped into the inkjet industry during my master thesis. And since then, worked for an R&D as an R&D role in a machine manufacturing company, and then moved to Seiko as a sales person, taking care of accounts in Germany, Austria, and Switzerland. And slowly growing in that area. Now I'm the head of sales for the business for the Seiko printheads in the entire region of Europe, Middle East, and Africa, including India. So that's an additional part of the business.
Quite a broad remit there.
Right.
But Ali, particularly with Seiko's position as head manufacturer, but particularly interested in industrial projects. Is that right?
Absolutely, Fraser. I mean, we are a much smaller company when it comes to, the other Japanese giants who are manufacturing printheads. From the turnover point of view, as a company, Seiko is much smaller than the others.
Yep.
And our division, the print tech division, we call it the printing technology division, which manufactures printheads, develops and manufactures them. We have been focusing ourselves to go into markets where there is a need for a particular type of a printhead.
Yep.
And then we develop a printhead for that particular industry, and we bring it to the field. And we just work with a few clients and try to build that relationship with them to understand the needs, go fine tune the product, come out again, and do that kind of fine tuning. So just for an example, 2014 was when, we launched one of our printheads, the RC1536, and it was exactly as you said. There was an industry, there is the ceramic industry, and we said, okay, what is the requirement of this industry? What can we bring as a printhead manufacturer to this industry? And that's how we worked on it. We now currently have 38% of the market share in the ceramic industry. So that's how we tend to work.
Yeah. And we'll talk more in terms of the applications in a moment, because obviously we're going to talk a little bit about packaging today, but we're also interested to know what else you kind of are specialist in, or where your experience works well. For clarity's sake, I guess for you like working in the collaborations where you can tune the technology to fit the need, if that makes sense.
Absolutely, Fraser. So this is, taking that point of finding out what the market needs. It's very important for us to do a collaboration and go work with industry experts like Roland and find out what needs to be done from a printhead point of view.
Sure.
And then, do the testing, find a product, find an entire ecosystem where everything's working well, and then present it to the market, present it to OEMs, and give them a complete solution where they can then start with. And, I always say this, changing the time or reducing the time from lab to fab. So going from laboratory to fabrication. So that's the idea, basically.
Yeah. And you mentioned Roland. Roland, hi. We know each other very well. Tell us a bit about you. If anyone doesn't know you, tell us a little bit about your background. It's an interesting background, and also explain a bit about what you've been doing with Ali and Seiko, and in terms of the proofing side.
Yeah. So my name is Roland Biemans. I'm the founder and owner of Elements. We're a, let's say, practical consultancy firm that helps out with finding the right technology, the right people, and helping manufacturers and print shops in finding the right solutions, basically in inkjet printing. And my background is in software development first. So I was a minor shareholder in a software company that made RIP software color management. Then I proceeded to work for Hollanders Printing Systems, where we made large format digital textile printing systems. So printing, fixing, washing, cutting. Then I moved on to Italy to join Kion Digital, where we made several types of inks, mostly known for the sublimation type. So in essence, I know a little bit about software, hardware, and supplies. And in the past, we've made something like a competence center for digital textile printing. And more recently, we have done the same sort of thing here in the Brainport Eindhoven area, where with a co-development, we started to work on a print lab with a printing, testing, proofing platform hardware, where we could actually try and test different types of inks, different types of technologies, and then help the integrators and manufacturers and end customers to really do what we would call a proofing of printing. So not in the sense of what we would call a soft proof you would normally have in color management, but more in a hard proof, what Ali just said, that you want to collaborate and then first try and see that everything you do in a laboratory is safe and sound and will really fit the purpose, and then transform it into an industrialized system. This is also how Ali and I deepened our relationship over the last years, is that we spoke about several projects that we had where we had to print vertically and where we had to print from quite a distance to the surface. And in finding the right technology for our customers in this sense, we looked at the Psycho head, and we decided that this was the head for us on an industrial scale we could use in a laboratory setting in order to prove our customers that if you industrialize this, that this head for them would be a very good choice.
Okay. Ali, just before we talk a bit about the proofing element, just tell us a bit about the print head. You mentioned the RC1536. Just tell us a bit about that.
So RC stands for recirculation, and 1536 are 1,536 nozzles that can be actively triggered on the print head. So it's a 108 millimeters wide print head with continuous recirculation behind the nozzle plate. We launched this somewhere in 2014, as I said earlier, dedicated for a particular industry, which was ceramics industry at that point of time. And then we've been tweaking this print head and finding where it can be used other than the ceramics market. If it can be used for textile printing, if it can be used for corrugated packaging printing, if it can be used for flexible packaging, for making coatings, white coats, making varnishes, things like that. So anywhere where there is a requirement for this kind of an application, for this kind of a print head, we tend to work with people in the field and get their feedback as to what are the points in our printer that can help them.
Yeah.
Right. So in a simple way, which I can give you an example of, is a white ink. White ink, you normally want to print a white ink on a flexible packaging because you want to create an opaque layer so that you can print the colors on top of it. And to get a real opaque white, you need a higher pigment size, and also the density of the pigment or the content of the pigment in the fluid, in the ink, needs to be higher. And so we work with one of the ink manufacturers out there, and we asked them, okay, so you go ahead and create an ink which you think is not jettable with a normal print head, and we will just see if it works. but it should just suffice the needs of the market. It should be opaque, and it should be it should create that effect of a layer where you can print on top of it. So that was the idea. And the ink manufacturer created something. Obviously, it was not jettable. And then we said, okay, no, we need to tweak something. But we came to a conclusion, where the opacity, we could reach about 95% opacity. And we could also jet it with our printhead. So it was on the edges of the printhead, the physical parameters of the printhead, but it was still possible. So this is something what we want to do and what we tend to do. And the printhead itself is quite flexible. It's quite robust because it's industrially made. So we print at higher print caps. We print viscous fluids. I mean, we don't need to tell the printhead exactly which viscosity it has, the fluid has, because there is a voltage temperature curve, so there's a temperature sensor in the printhead itself. It reads the temperature, adjusts the voltage. So if your viscosity is changing, your printhead is automatically able to adjust everything.
Yeah.
So wide range of printing flexibility.
So versatile, and that means versatility with the inks, different inks. Is that right? Flexibility in inks.
Absolutely. That's a good point, Fraser. Because initially, when we launched the printhead, we launched it only for the oil-based inks.
Yeah.
For that market, for the ceramics market, and then when we moved on away to corrugated, we went into UV-based inks.
Yeah.
Then we moved into textile, and into water-based inks. So. Sure. There was a tweak required every time when we were moving. So, we needed to tweak the glues that we use inside the printhead. Yeah. We needed to tweak the coatings that we do inside the printhead. And the entire production process was then developed for that particular application. One thing what I would like to mention is, despite making these changes, we are making sure that the new product is backwards compatible. Right. So, the older generation machines can just swap with the new printheads, and they're capable of printing the new technologies that are coming in the market.
Yeah. And vertical, horizontal printing, multi-pass, single pass.
Exactly. I mean, vertical and horizontal printing, this was something, normally with this 108 millimeters, you're normally printing in a single pass mode. Yeah. So you're creating an array of printheads. You don't need many printheads because it's a very wide printhead. So the total cost of a print bar would reduce. So, if you, for example, have a 50 millimeter printhead, then to make 1 meter, you would need 20 printheads, 20 electronics, 20 ink systems, and it just multiplies. Yeah. Now with 100 millimeter printhead, you're reducing the number of electronics you need.
Yeah, and the cost.
Absolutely, and the cost. So, when you go to the industry and you say, this is the cost of the machine, then they understand, okay, there is certain cost of digitalization, which is obviously a little bit higher, but the benefits are much more when you have such a kind of a system.
Yeah, sure. Roland, let's talk a little bit more about the proofing element and the 3 steps of proofing. So fill us in, the sort of soft proofing, hard proofing. You tell us a bit more about that.
Yeah, what we often see is that with new customers coming in, so they either come from a traditional analog area, or they are already in a digital area, but want to change to, let's say, doing coatings and doing post-treatments, doing something more than, let's say, ordinary inkjet, so more on industrial scale, that they start off a development cycle and then don't know what to expect. So, and that's also true for head manufacturers, ink manufacturers, all the parties involved will then look at what they think would be the best options to put together. Beforehand, it's rather difficult to already say, in the end, this is going to be the end result, because a lot of that is theoretical, so it's not practically put together yet. So what you would normally do is first look at what we would call a soft proof. So this is more the column management term of mimicking something on a substrate that might be different, with an ink that might be different, but that shows you that it is possible. So color-wise, that the text is legible, that the colors are in the right space. But a soft proof is specifically made for, this is something that you see on screen and it should be coming out like this in the end. So then the hard proof, that is more what we envision to do, is that you would then take the actual hardware and the actual ink and the actual substrate media to make laboratory level proofs that are really a hard copy of what you will get in the end, because the technology that you're going to use is going to be the same technology, albeit bigger and more and industrialized later on. And then in the end, when you've delivered your proof of concept in the laboratory and you turn it into, let's say, the end product, so it could be an integration in an existing packaging line, or it could be that you digitize, let's say, the offline proofing system that stands next to the high volume system. You could make a hard proof, basically saying, this is exactly what you will get. So right. It's like a reference level that after a year, when stuff starts to change, maybe you want to change a head, or you change a little bit of the formulation in the ink, or maybe you have to switch out RIP software, or that at least you can go back to your contract proof or your hard proof, where you can say, look, this was the reference. We wanted to have that 95% opaqueness in the white, for instance. Something has changed. Let's go back to the situation we had in the laboratory before we actually made the step to the bigger industrialized version.
Yeah. Ali, did you want to make any comment there?
Right. I just wanted to, say that, before Elements came on board, it was very difficult for us as printhead manufacturers to show what's possible with the printhead.
Yeah.
Because as a printhead manufacturer and not having any machines, that, like Seiko printing machines. So, it's very difficult for us to show. You can do that. I mean, I'm telling you, you can. We've done some testing. We've done, we can show some samples, but people don't, I mean, it's not easy for someone to just believe that, So when Roland actually put forward that idea of creating this kind of a proofing system, where in the initial step, as a sales guy, I will go on and I'll say, okay, you know what, we can print this opacity. We show something, and we show printed substrate with, where magically inkjet has worked and you have got 95% opaque, opaque layer. That's what they think, it's magic. It's not right. It could not be possible with inkjet. And then you're like, okay, I'm sure you don't believe me that I've done that just in single pass, without any pre-treatment. The ink has worked very well. The printing was not done with any special, waveforms or things like that. So what we'll do is we'll invite you to our lab, the lab that we've created together, and we tell them, okay, we will show you the first step on our substrate with the inks that we have created.
Yeah.
And we'll show it to you. You can see what's possible with our technology. And that's the soft proof stage, that we say, okay, it is possible. And that was not possible before. So as a printhead manufacturer, I'm very happy. And that's the motivation that we have to work with Elements.
Yeah.
And going from that soft proof, as Bruno already explained, going to hard proof, where you take the inks and the substrate that the customer really wants, and going to the contract proof. So, it's that always the going from lab to fab and making that possible in a very short time.
And how, in particular, with packaging, do you think this is useful? Why is it so valuable, particularly with the packaging sector?
Well, if I look at it, is that you have the differences in quality expectation and speed expectation.
Yeah.
So if you do brown box printing or you do white box printing, let's say the coding and the marking on one side, or the graphical decorative stuff, then there's a difference in expectation of the quality level and also the speed level in the end. So the proofing and the packaging comes from the fact that you do a media change. So we see in the sustainability side of things that we've also seen during all the other talks in Cambridge, where you would see that there's people are shifting more towards a sustainable area. So quite naturally, then the material will change. Or maybe people want to include digital coating or pre-treatment on it. And this is something that doesn't exist then yet. So you have to change something. This is something that you don't want to do on your high volume system.
Sure.
So you want to do that offline, but with something that is same or similar as your high volume system.
So you actually think that general trends in the packaging world are influencing the need for this kind of approach?
Also, yes.
Yeah. Ali, you were going to say, make a comment.
I was going to say, I mean, for us, the first thing is inkjet is quite new into packaging.
Yeah.
It's something that is still not there. But having said that, I must also say that packaging is a very matured market. Because, I mean, everything has been being packed since ages. So, the requirements are quite high. And we need to tell the market with inkjet, this is what's possible. You can't just go and say that what you want, I mean, the last, whatever is possible with analog, you're going to get exactly that same thing with digital.
Yeah.
Not going to be possible. I mean, there are some limitations that you have to look at. And with this kind of a proofing system, we're making it clear that these are the advantages and these are the disadvantages.
Yeah.
And then we need to work together and find out how best we can bring a solution to the market.
Yeah. And does this have a relevance when you're talking about the different inks, the water-based inks and obviously in terms of the contact with food, for example?
Absolutely. I mean, when you speak some flexo, printing presses, today they have one ink, tomorrow they have another ink.
Yeah.
They can change the inks so fast. It's possible. That technology allows them to do that.
Yeah.
And that kind of a mentality, when somebody comes in and says, I want to do that digital inkjet, you have to put the brakes and you have to tell them, guys, it's not possible.
Yeah.
Everything in the printhead needs to be checked. The ink system needs to be, adapted for that particular ink. So the waveform needs to be created. So there are a lot of things that needs to be done, and that's knowledge that fails currently in the market when it comes to moving from analog to digital in the packaging field.
Sure. I just want to check. I know that print gap is important and throw distance, and I know this is unique to Seiko's head. So, Ali, just explain why that's relevant and why it's valuable, particularly in different applications.
Right. So we come from a market, where throw distance has always been something very critical, and the manufacturers of our machines and also the end users see this as one of the important points when deciding for a Seiko technology. So, I mean, going back a step, we have in the manufacturing process, when we are manufacturing our printheads, in the quality assurance step, we're waiting for the printheads. Once they come in, each and every printhead is tested for performance at a gap of 3 millimeters. Other printhead manufacturers, our other printheads also actually are tested at 1.5 millimeters print gap, except for the RC1536. The RC1536, with its shear mode technology and what I was explaining earlier, it allows for these drops to be deaded with an exceptional directional accuracy. The drop volume, the drop velocity, and everything is measured at 3 millimeters, allowing users to use that additional gap. Now, why is this gap important? We keep saying print gap. So I'm just going to give an example. We have some customers who have made machines for the corrugated printing industry.
Yep.
And the corrugated printing, these kind of boards, these kind of cardboards are really not things that people want to put money on. It's something really cheap. It's something that people buy in bulk, and still we need to make a good enough print on it so that the end user or the buyer of the goods that are inside, they can see the marketing that's being done and then pick up the product. So, it's a two-way thing, right? On one side, you don't have too much money to put on the decoration of that corrugated board or the corrugated packaging. But on the other side, it's important that the quality of this corrugated packaging is good. So the source of these corrugated boards is not so good. That's the first thing to remember.
You mean the quality sometimes is not great, and therefore it can be a bit curved or bumpy, or So the print gap makes the difference, doesn't it?
Absolutely. So you just think of my hand as a corrugated board that's coming in. Yeah. If it's like that, it's just going to bang into the print heads.
Sure.
These they cost in cents, and the print heads are a little more expensive than that. So these kind of small cardboards would just ruin a print head.
Sure.
That additional print cap, even a millimeter or 2 millimeters, changes everything.
Yeah, no, I understand.
It the life of the print heads finally.
That's really important, isn't it? And Roland, I know that you have experience in other markets, textile and things like that, and carpet. So is this relevant?
Very, because you really want to not have any head strikes. So when the head touches the substrate, then that's going to be a disaster. But if you look at the very different types of applications, textile fibers sticking up, we now have a project I cannot go into too much detail, but where the throw distance or the print distance is really helpful, is because it's on a different types of substrate where otherwise we would have to move the head in and out. So then the engineering would be very expensive. But if you have a head that can perform at a longer distance, then we could also simplify the engineering of the end product that will become an industrialized solution. So from all the application forms that we have seen, and with that throw distance, we think that this Psycho head for us performs the best. So that's why we chose it mainly for these types of applications.
Yeah. And actually that leads us nicely, as we come to the end of this session, to just finally kind of point to the collaboration between the two organizations and how important that is. Roland, for you, I mean, obviously you can work with lots of different companies. Why has it been good, this collaboration?
Well, we are technology agnostic, so yes, we could choose any and everything. So based on what customers would ask or what they would need. But Adi and I have been talking for a long time now, but more thinking outside the box. So it's not just talking about this is a specification sheet and these heads are good on paper. But Ali and I actually started to speak about different types of challenges and how you could cope with them. And if I look at it from our perspective, we're often in a situation where people come to us with a request of proof of concept that doesn't exist yet. So that's why we have that proofing platform that we can help out people. But then if we would go to manufacturers or suppliers, then often their question would be, so how many units or how many liters or how much are you actually going to take? And then sometimes our answer is, well, just one, which is from a commercial point of view, if you look at it from a startup perspective, not that interesting. But if you look at all the different possibilities you could get from this type of collaboration, then that is a difference. And I have to say, Psycho earlier this year has made this open house. So it was a complete week of collaborative get together of people that really want to solve problems or head on with challenges and not just talk about.
Yeah.
Here's a head or here's a machine, and now you have to take so many units of it.
Yeah. So it's very much about collaboration. Ali, anything you wanted to say? Final comment?
I think Roland summed it up really well. It all started with these Friday coffee with Roland sessions that I used to have.
Sounds nice. Sounds nice.
Yeah, and the kind of ideas that we at Seiko have and what Elements have and what we want to bring on the table is quite the same, and that's what we said, why not do it together? Yeah. And we created the ADL, Applications Development Laboratory in Frankfurt, and having this kind of collaboration with JetProof and with Elements, and bringing this kind of an additional setup where things can be brought together, going from soft proof to hard proof to contact proof, things like that. This is a very nice concept, nice way of bringing things from laboratory to fabrication. And we're looking forward to pitch in a little bit of the shift from going from analog to digital in the packaging industry.
Yeah, absolutely. Gentlemen, thank you very much for your time. Been very interesting. Good to hear about the collaboration. Good to hear a little bit more about the actual heads and what's different about them. Thank you to both of you. Hope to catch up with you soon, face to face.
Yeah. Thank you very much.